Hey everyone, welcome back. I want to start with something that you've probably seen several times already, and it's this diagram that you see here. It's an application that calls a model, the model responds back, and that's all. So most of the tutorials or the quick start shows this architecture because it's simple, and to be honest, it works. But the moment that you take this pattern into a real enterprise where you have multiple teams, multiple applications, real users, and real costs, this will start breaking in ways that are very hard to debug. Keys floating around, environment variables, or a lack of tracking to know what is the application doing, or if you have a batch job that can take down everyone else's quota, and so on. Today I'm going to show you an architecture that solves this, and it centers on Azure API Management as an AI gateway. And by the end of this video you will have the full picture, so let's go. Before I show you the solution, I want to make sure that we are in the same page about why is this a problem. AI traffic has three properties that make it different to other type of traffic. First, it is expensive, very expensive. You could have one batch job running one night and come the next day with one bill of 4,000 USD. Second, because quota it's token based, not request based. Azure OpenAI and other LLM providers measures limits in tokens per minute or TPMs. And last, because almost always this is a shared resource. So you will have one OpenAI deployment and several applications or teams hitting it at once. That is the problem in a nutshell, so let's see how we can fix it. Azure API Management is not at all a new service. It's been the enterprise API gateways for several years, and it's one of my favorite services. But in the last month, Azure has added a dedicated set of AI gateway capabilities, specifically designed for language model traffic. So the concept that we are talking here is very simple. It will act as a reverse proxy. So instead of each application calling directly Azure OpenAI, we will place Azure API Management in the middle, acting as a control plane. From this place, it can handle authentication, quota limits, login, and several things more. The key insight here is that APIM will be the central place where we will handle authentication, token limits, login, caching, routing, and so on. This will give us a central place for AI governance. If there is a new application that wants to connect to an OpenAI model, you can just create one subscription key, assign a token budget, and that application get access automatically to OpenAI without having to handle any OpenAI key. The single and most important security change that you can make when moving to Azure API Management is eliminating API keys from the path between APIM in Azure OpenAI, and the way you do so is using managed identities. In this case, APIM will have a system managed identity that then needs a role assignment like a user OpenAI, and the workflow will look like this. An application will contact API gateway using a subscription key. That subscription key, APIM can rotate it or scope it to only one API or product. Then from here, Azure API Management will handle the authentication to Azure OpenAI. And the way it works is as this. APIM will have a policy in the inbound that will make a request to Enter ID with its identity. Enter ID will validate that it has the role assignment and will return a bearer token. Then APIM will add that bearer token authorization and will send the request to Azure OpenAI to validate that token. Here's how the Bicep would look like. When you create the APIM instance, there's gonna be a block called identity, and in this case, it's gonna be a system assign. You could also use a user assign identity. The other setup that you need to do is add the role assignments. For this case, OpenAI user is the one, and the GUID for that role is this. So with that GUID, what I'm gonna do is I will add the identity of APIM to that group, and this is the part that will allow APIM to request a bearer token from Enter ID. Then in the inbound policy, you will have something like this. APIM will need to make a request to Enter ID for a bearer token. Then it will set a header or override if it already exists called authorization, and it will pass that token that it gets from this request. And optionally, you could remove the API key if it exists already. This is a clean separation of concerns because the applications authenticates to the AI gateway, and then the AI gateway authenticates to the OpenAI model. In this way, the model never has public facing credentials in the code or environment variables. If you want to go fully keyless end-to-end, apps authenticating to APIM can also use Enter ID to issue tokens or any other identity provider. And then APIM supports something called GWT authentication that can validate that token. Now let's talk about the noisy neighbor problem and how to solve it properly. When you make an OpenAI deployment, it assigns a total TPM quota for that deployment. But if you have multiple applications that are consumed, nothing is preventing for this support bot to consume all tokens. But APIM gives you a solution for that with one policy called Azure OpenAI-token-limit. This is the APIM policy that enforces that. The key part is counter key, which will be related to the subscription key for each application. So let's say that I have 3 applications, the bot, the batch, and one external application. For the bot one, I will assign tokens per minute 10K. And for the batch one, I will assign 100K. So the quota for each application will be isolated even though they are using the same OpenAI model. And they will get a 429 error if they exceed its own quota, which won't affect the other application. There is another mechanism that can help you reduce the consumption of token. It's called semantic caching. Caching for traditional APIs are binary. A request either matches or not. But for prompts are quite different because 2 prompts can mean the same thing even if they are using different words. Semantic caching solves this by comparing prompts in a vector space. So APIM uses an embedding API call to convert any income prompt into a vector and then checks that vector against cache responses that are stored in an Azure Managed Redis. So if the similarity score is above a threshold that you define, then it returns that cache completion directly. So there's not gonna be any model code at all. The last architectural pattern that I want to cover with you is resilience. And this is where backend pool features become critical. The problem with having only one OpenAI deployment is obvious. If that deployment hit its PTU capacity or if there is any regional service disruption, then your application goes down. APIM solved this with something called named backends and a load balancer pool. So we define different backends, in this case we're going to be OpenAI deployments, ideally across different regions, and then we configure the load balancer to route traffic across these backends. Here is the Bicep for individual backends. So we define the backend for primary, then a secondary, and also it's a common practice to have a backend fallback when both are failing. So this one will be, let's say, in ECS2, and this deployment will be in central, and then this in another region. Then in this part is where we define the backend pool. We specify what are gonna be the backends. Both the primary and the secondary will have priority 1, and then the fallback it's going to have a priority 2. The circuit break configuration is built right into this backend definition. And basically when APIM sees a 429 or 500 errors for 10 seconds, it will stop sending traffic to this backend for 30 seconds. Then in the APIM policy, you reference your pool instead of the OpenAI URL directly. Now let me put all this together into this full picture architecture. At the top, we have our applications. We'll connect directly to Azure API Management instead of the Azure OpenAI deployments. Inside Azure API Management, we have defined different policies at the inbound, outbound level. For inbound, we have GWT validation or subscription key, depending on which method we design to authenticate to Azure API Management. We have the Azure OpenAI token limit that we saw to isolate tokens per each application. We have semantic cache lookup to reduce the tokens consumption using the semantic search. And then we also have the managed identity authentication to the backend using the identity of APIM. We also have here in the left the Azure Redis. Remember that to use semantic search, we need to have a managed Redis instance. And here finally, we also have observability to know what is the usage for each subscription or the calls that we do to the backends. I know that APIM is not the simplest path to getting Azure OpenAI working. The simplest path you already know, just your app calling Azure OpenAI directly. But the pattern that I've shown you today is what separates a demo or a POC from a real production AI platform. And this pattern is what enterprises are using. So you decide. So I hope that you find this video useful. Subscribe and like for more content like this.